Hey guys, today this is going to be quick and easy, I think. I just wanted to kind of go over where we're going in Chapter 4 here and give you some answers from yesterday's homework to make sure you know what you're doing and you can work on today's homework more effectively. So let me start by showing you where we're going with Chapter 4. You're going to see there's not that much to it, really. Let me adjust this. Okay, so this is actually the test from Chapter 4 last year. And look, there are just three things that we are doing. We are describing the form, direction, strength, and outliers of a scatter plot visually. And we're calculating the correlation coefficient, right? That's the R value. So you need to know how to calculate that on your calculator. That's the first thing, right? That R value is related to all of this. Then we want to also be able to use our calculator to find the equation for the line of best fit, right? That's called the least squares residual line. And we're going to use that equation to make predictions and interpret the slope and the y-intercept of the line in the context of the problem. So both of these things we have already done in 2 assignments. And we will keep practicing them a little bit. And then last, we want to be able to simplify expressions with exponents and scientific notation. And we're going to continue to practice that. But you can see a lot of this you, at this point, probably already know how to do somewhat. So those are the three things, right? Exponents, scientific notation, and then all this stuff with your calculator. So let's look at yesterday's assignment. A little bit higher. Okay. So I really just want to go over this first problem and make sure you know how to use your calculator properly. So you should have put all of this data into your calculator in like the L1 and the L2 columns. And again, if you're not sure how to do that, the back of the notes for section 4.1 has all of the commands to use, all the buttons to push on your calculator to help you do stuff. And then I describe how to do that in the video. So hopefully you have created the scatter plot. I hope you learned how to use your calculator to actually look at the scatter plot and look at the line of best fit. It's kind of cool, actually. And so you should have used your calculator to get the scatter plot. And this was the first thing on our on the test I just showed you. Can you describe the association? You should have found out for this one there is a strong negative linear association with no outliers. That is a perfect description, right? There's 4 things you need: strong, moderate, or weak, positive or negative, linear or nonlinear, and how many outliers there are. Those are the 4 things we use to describe a scatter plot graph. And then the equation. And what did we round to? There's hundredth. Okay, so you should have got y equals negative 1.58x plus 5.37. So if you're not getting that, I really hope you'll come to AO or extensions and check in with me, and let's figure out why the calculator is not giving you the same answer as my calculator is giving me, I guess. All right, and then you should be able to describe the slope in the context of the problem. What does this number right here, this negative 1.58, mean in the context of the problem? Well, this is your x, and this is your y, and the slope tells you how the y is increasing or decreasing. So in this case, the negative 1.58 tells you that the number of days the cold lasts is decreasing because it's negative. It's decreasing by 1.58 for each month that you take the supplement. So if I take this supplement for a month, my cold will last 1.58 days shorter. And for each month that I take it, in preparation for cold season, my cold will last 1.58 days less than it would have. What does the y-intercept tell me? Well, the y-intercept tells you how long the cold would last if x were 0. So if I took the cold supplement for 0 months, or nobody would say that, right? They'd say, if I did not take the cold supplement, my cold would last 5.37 days. So, a little less than a week. So that is data that whatever company makes this cold supplement might want to put in a commercial. That you can have your cold last a day and a half less for each month you're willing to take the supplement. Right? And it would last for 5.37 days if you didn't take the supplement at all. Letter E. How long do you predict a cold will last for a person who has taken 6 months of supplements? So mercy, they must have started in like April for getting ready for next winter. But you would do that by taking your equation, right? And you'd put 6 in for x. And you would calculate what y equals, and y would equal negative 0.411. So technically their cold would last negative 4 days, which means, supposedly they would not get a cold, because your cold cannot last for 0 days. And their correlation coefficient, right, the R value. Hopefully you found out that the R value is negative 0.95. And what does this tell you? It tells you there is a negative, strong, linear association between these two things. There is a strong association between the number of months you take the cold supplement and how many days the cold will last. Again, that's something that the company that makes the cold supplement would want to put in a commercial. They would want out there that there's a strong association between how long you take their supplement and the number of days the cold will last. Okay, so that is how you would do number 1. We'll talk about 2 and 3 in class tomorrow. But I want to talk about number 4 real quick, at least a couple of them. So letter C, multiplying numbers in scientific notation. I want to talk about how to do this the easy way. The easy way is you just multiply these two numbers together, so that would be 12, and you add the exponents, because when you're multiplying stuff together, the exponents get added. This would be 12 times 10 to the 8th. The problem is, that answer is not in scientific notation, because this number has to be between 1 and 10 for it to be in scientific notation. So then you would take the decimal in the number 12, and you would move it one spot so that it's between the two numbers. It'd be 1.2 instead of 12. But when you move the decimal one spot, that affects the exponent. And as this number gets smaller, it goes from being the number 12 to the number 1.2. To make up for that, the exponent needs to get bigger by one spot. And your answer would be 1.2 times 10 to the 9th. Again, I'll talk about that in class tomorrow again. How about dividing numbers that are in scientific notation? Well, to divide numbers that are in scientific notation, you actually divide this part. And if you divided that part, I think you get 0.84375. And when you're dividing, you actually subtract the exponent. 4 minus negative 2. And 4 minus negative 2 is 6. So this would be your answer, kind of. Except again, this number is not between 1 and 10, so I need to move the decimal one spot and make it 8.4375. And when I move the decimal one spot and I make this number bigger, the exponent has to get smaller by one spot. And this would be your answer. Alright, the rest of the problems here are practice with exponents. Some of them are kind of tricky. We'll see how you did in class tomorrow. I think that's it. I really just wanted to talk about scientific notation a little bit and make sure you could use your calculator again. If you have questions, please come see me in AO or Extensions. I'll be monitoring my Zoom during that time, so just check in, and good luck on the homework tonight.